So in this video, we're going to be talking about the real number system, and there's really two groups of numbers within the real number system, and that's going to be rational numbers and irrational numbers. So rational numbers are just any number that can be written as a fraction, and that's going to include any terminating decimals and repeating decimals. And then irrational numbers are obviously going to be any number that cannot be written as a fraction, and these are going to include decimals that have no pattern that never end. So let's go ahead and look at some examples of what a rational number would be. So our first example would just be the number 10, okay? 10 can be written as a fraction, and that would be 10 over 1, so it's a rational number. Next, we have 2 over 3, or 2/3, and obviously it's a fraction, so it is going to be a rational number. But if we write it as a decimal, it's going to be 0.6 repeating, which also falls underneath the umbrella of rational numbers because that is a repeating decimal. Next up, we have -6 over 5, or -6/5, and same thing, that's a fraction, so that's obviously going to be rational. Our next example is 0.57, and that's going to be a terminating decimal, so obviously that's a rational number. Next up, we have 0.2 repeating, and any repeating decimal is always going to be rational. Next, we have -3, and -3 could be written as -3 over 1, and so that's going to make it rational. And then the last one would be -237, which same thing, you could write that as -237 over 1. So rational numbers are just pretty much the numbers that we use more often on a day-to-day basis. Okay, they're the numbers that we think of whenever we think of numbers. Now, on the other hand, we have irrational numbers, and again, these are numbers that cannot be written as a fraction. So first up for irrational is the square root of 10, and what makes it irrational is that if you were to put it in a calculator, you would get 3 and then you would get all these decimals that don't repeat, okay, there's no pattern, and they never end, so they don't terminate. And so that's what makes it irrational. Another way of thinking about this is that 10 is not a perfect square. If we take the square root of it, we're not going to get a whole number. Okay, the perfect squares would be 1, 4, 16, 25, 36, and so on, because if you take the square root of those, you're going to get a nice whole number. Next up, we have pi, and if you were to write out the decimals for pi, it would never end, and there's not really a pattern, and so that makes it irrational. And then for our last irrational number, we're going to have the square root of 5, and once again, 5 is not a perfect square, and so whenever we take the square root of that, we're going to end up getting a lot of decimals that don't have a pattern and that never end. Now, within the group of rational numbers, we also have a few other ways that we can classify numbers to be a little bit more specific. So the first group is called natural numbers, and these are also called counting numbers because you just start at 1 and you count up. So 1, 2, 3, 4, 5, 6, 7, 8, just going up to infinity forever and ever. All those are natural or counting numbers. Next up, we have whole numbers, and whole numbers are just all the natural numbers plus 0. So you start at 0 and you count up to infinity. All those are whole numbers. And then we have integers, which are all the whole numbers and their opposites, or the negative versions of those numbers. So I know that's a lot to take in, but the best way to understand this concept is to make a graphic organizer like the one on the screen right now. And so what we're going to do is just go through some numbers and we're going to place them in the correct position on the graphic organizer. Okay? So what we're going to do is place them in the most specific group we can. So first up, we have the number 34. So the most specific place for 34 would be natural numbers because it is a natural or counting number. Okay? But it's also a whole number, an integer, a rational number, and a real number because it's in all those sets. Next up, we have the number 0, and the most specific we can be with 0 is to place it within whole numbers, okay? So it's going to be a whole number, it's also an integer, it's a rational number, and it's also a real number. Next up, we have -13. -13 is going to be an integer, and so therefore it's also a rational number and a real number. Next up, we have 2/3, And 2 over 3 is going to go in the rational numbers, and obviously it's also a real number. So lastly, we're going to have pi, and it's an irrational number, and it's also a real number.